This is lesson 2.6, drawing scatter plots and best fitting lines. Now a scatter plot is simply when you graph points from a table. And you look at those points and you try to determine, do they follow a pattern? And if they do follow a pattern and that pattern goes uphill like a line with a positive slope, we call that a positive correlation. If that pattern goes downhill from left to right, that like a line with a negative slope, we call that a negative correlation. And how closely those points resemble a line is called the correlation coefficient. Now in statistics, that correlation coefficient is represented by letter R. And so now that number is a value that goes on a scale. And so that scale actually goes from -1 to +1 with 0 in the middle. Now if you have a positive correlation, then the number for R will be between 0 and 1. And when you get out here to 1, that is a perfect line. So when you plot the points, if they all lie on a perfect line, the correlation coefficient is 1 if it has a positive slope. Now if it has a negative slope, on the other hand, then to be a perfect line, the slope would be, or the points would lie on a perfect line if the correlation coefficient was -1, and that would show a line with a negative slope. Now oftentimes the points though do not reflect a perfect line. It's somewhere between 0 and 1 or 0 and -1. And what we want to determine is what is the best fitting line for those points. And in statistics this is called linear regression. And so that's what we're going to try to do in this section, is find the equation of a best fitting line that correlates to data. Now let's take a look at example number 1. It says, for each scatter plot, describe the correlation shown, whether and tell if the correlation coefficient is closest to which of those numbers. So let's look at letter A. When we look at letter A and we look at those points, they kind of resemble a line that is going downhill like this. So I would say that this scatter plot shows a negative correlation. Now since those points are pretty close to that line, none of those points are very far away, I would say that's actually a fairly strong negative correlation. So the closer the points are to the line, the stronger it is. So the best estimate for the value for R, now since it goes downhill, it's going to be between 0 and -1 here. And you know, -1 is a perfect line, but -0.5 is my only other option. And since those points are pretty close to the line, I would say it's closer to a perfect line than it is not. So I'm going to say that R is about -1 in that case. It's not exactly -1. It might be like -0.8 or -0.9, but it's closer to -1 than it is anything else. When I look at letter B, now this time my pattern kind of has an uphill slope to it. Again, it sort of resembles a line with an uphill slope, but those points are not quite as close to the line as they were in letter A. So I would say that this shows kind of a medium positive correlation. Since it goes uphill, it's positive. And so R here in this case would be between 0 and 1, but not too close to either one of those. So I'm going to estimate this to be approximately 0.5 for the value for R this time. So that's how the correlation coefficient works. All right, so moving on to example 2 here, we want to try to approximate a best fitting line for a set of data. Again, this is called linear regression in statistics. The table below gives the number of people, Y, who attend each of the first 7 football games, X, of the season. Approximate the best fitting line for the data. So the first thing we want to do here for this data is we want to draw a scatter plot. And so To draw a scatter plot, we just simply plot the ordered pairs. So 1, 722, it's going to be about there. 2, 763, 3, 772, 4, 826, 5, 815, 6, 857, and 7, 897. So there's where the points would be, and as you look at those points, they do sort of resemble a line that goes uphill. So it looks like a positive correlation in this problem. Now, one way we could do this by identifying 2 points that go through that best fitting line. So what we might do is we might draw a line through these points. And so if I was to draw a line through those points that I thought best fit those points, it might look something like that. And then what I would do is I would pick the 2 points that are closest to that line and then use those 2 points and find an equation. Now, in the notes here, they suggest that we use the point 1, 722 and 2, 763. However, I'm going to suggest if you use the point 2, 763, that would not be a line that goes through those points very well. So I'm going to change that. I'm actually going to use the point 7, 897. So let's use those 2 points. I think those better represent the line. So first thing we want to do now that we have 2 points that line goes through is we can find the slope. So that's going to be 897 minus 722, that's the difference of the y's, over 7 minus 1, that's the difference of the x's. So let's see here, 897 minus 722, that's 175. And then 7 minus 1, of course, that's 6. And so there's my slope. Now, as a fraction, 175 over 6, we may want to change that eventually to a decimal, but we'll just leave it that way here to start with. Okay, so I need to move this down slightly so that I can work with this a little bit better. So my points were 1, 722 and 7, 897. And so we found out that our slope was 175 over 6, remember. Okay, so let's pick one of those points to use. Let's just pick that first one. So I'm going to have y minus 722 equals my slope, 175 out of 6, times x minus x1, which is a 1. And so if I move over here on the side, y minus 722 will equal 175 over 6 times x minus 175 over 6. And then I want to add 722 to both sides. Now here's where you might want to go to your calculator to do this. Change it to decimals maybe. So 175 over 6, that's approximately 29.2 approximately. So we're going to say y is approximately 29.2 times x. And then when I add 722 to that, that's about 692.8. Okay, so our approximate best fitting line then, y is about 29.2 times x plus 692.8. So that's the equation of that line that best goes through those points. Now, once we find that equation that best fits our line, then we can move on and we can find we can use that equation to help us predict things. It says, use the equation of the line of the best fit from the previous example to predict the number of people that will attend the 10th football game. So the number of the football game, remember, that's our x. So because we're predicting the 10th game, we're going to substitute 10 for x in the equation from example 2. So remember, our equation looked like this. Y is about 29.2 times x plus 692.8. So we're going to go 29.2 times 10 plus 692.8. And so I'm going to go to my calculator now to figure that out. So 29.2 times 10 plus 692.8, and that's about 984.8. Or in other words, we can predict that about 985 people will attend the 10th football game. So this process of finding a best fitting line can help us make predictions about things. That could be very good if you were especially working with finances or working with populations, or things that you have to, when you have to make predictions about things into the future.